Let's tackle our three switch network here, and we've got a full mesh in this one. And what you'll see on the next screen are the MAC addresses and the bids of the switches. You might want to jot those down. And we're going to follow with a look at the election from each switch's point of view and kind of decide what we think should have happened in the root bridge election. And then we'll see what happened in the root bridge election. This is an excellent kind of practice exam question too, a huge one I grant you, but you've got to be able to look at a diagram such as this and some MAC addresses and be able to say, well, here's the root bridge. You've got to be able to say, here are the root ports that the non-root bridges are going to select. Where are the designated ports? Well, here it is, or here they are. How many ports will STP block once convergence is reached? All excellent questions for this kind of network. And let's check out the answer on live Cisco equipment. We've got our switch MAC addresses. And you can see switch 1 000F 90E2 2540. Switch 2's MAC is 0022 91BF 5C80. Switch 3 0022 91BF BD80. The priorities and port speeds have all been left at the default, so that makes the priority for each switch 32769. We take the default priority of 32768 and add the VLAN ID. Now the resulting bids all begin with 32769. That shouldn't surprise us. And let's talk about what happened during the election, assuming that all three switches were turned on at the same time. Now, switch 1 is going to see BPDUs from switch 2 and switch 3, and they're both saying, hey, I'm the root. Well, from switch 1's point of view, these are inferior BPDUs, because look at the bids on the screen right now. These are inferior BPDUs coming from 2 and 3 because switch 1 has a lower bid. Its MAC begins with 000. That is the deciding factor since the priorities are the same. And switch 2's, they both begin with 002. So it's all over right then and there. So switch 1 just says, hey, these are inferior BPDUs. They don't bother me. I'm still the root, and I'm going to keep sending out BPDUs that announce myself as the root. Now switch 2 is going to get BPDUs from 1 and 3, and they're both saying they're the root. Switch 2 looks at the bids in them, and switch 3's BPDU would be inferior to switch 2 because comparing those two, they're tied for a long way, 002291BF, but then right there, switch 2 has a 5 and switch 3 has a B, which is hex for 11. So we know that switch 2 has a lower bid than switch 3. So, no problem there. But switch 1 has a superior BPDU and is sending that in. Switch 2 looks at it and says, okay, this guy's bid is lower than mine. That is the root. And from that point on, switch 2 will forward BPDUs that it receives announcing switch 1 as the root. I know I've got BDPU there. I'll fix that. Now, switch 3, it's about to start developing a massive inferiority complex because it's getting BPDUs from switch 1 and switch 2, and they're both superior. So since the BPDU from switch 1 has the lowest bid of those two BPDUs, switch 1 is going to recognize, switch 3 will recognize switch 1 as the root, and when it gets BPDUs announcing that, it will forward them. So now we've got a couple of port assignments because as the root switch, switch 1 is going to have both ports placed into forwarding mode, and I'm going to show you the output of show spanning VLAN 1 with that lab. And both of these ports, you'll notice, are designated ports. So here's switch 1 and here's show spanning VLAN 1. You can see a couple of different ways that it won the election. The MAC addresses are the same under root ID and bridge ID. We have this subtle little message right here. This bridge is the root. And let's see, both of these ports are in forwarding mode. Another way you can tell is that both of the ports that are in forwarding mode are called designated ports. That will be the role here. Again, you will not see root here. Root bridges don't have root ports. So that is show spanning VLAN 1, and that's the information that we really want to see. That's what we expected to see, knowing or putting together what we learned in earlier videos. So now what happens? Well, switch 2 and switch 3 have to select their root port. Each non-root bridge has two different ports. Excuse me, that ran away from me there. Switch 2 and switch 3 need to select their root port. Each non-root bridge has two different ports that it can use to reach the root. But the thing is, the cost is lower for the port that is physically closer to the root bridge. That is not always the case, but we are assuming here all port speeds are the same, and they are because they're all fast Ethernet ports. Now, these ports will be selected as the root port on their respective switches, again verified by show spanning VLAN 1. So let's go over to switch 2 and run show spanning VLAN 1. And you can see right here that switch 2 has got fast 11 as its root port, and it's in forwarding mode. That's the port we're really interested in right now. If we go down over to switch 3, fast 011, root port, forwarding status. So we're again seeing what we expect to see, and that's where we are at this point with this diagram, where 4 ports so far are in forwarding mode. And switch 2 and switch 3 have selected port 11 as their root port, so that will be put into forwarding mode. But we have 2 ports left. We're almost done, but not quite. Now, switch 2 or switch 3 has to be chosen as the designated bridge of their common segment, their little connection over there. Now, the switch that advertises the lowest cost to the root bridge, that will be the designated bridge. And the switch's port on the shared segment will be the designated port, the DP. Now, in this network, switch 2 and switch 3 are going to advertise the same cost to each other over the shared segment because they are both, one port away, and that port cost is 19. So the port cost is the same. The cost is the same. What happens if there's a tie like that is the switch with the lowest bid, and there's that phrase again, the switch with the lowest bid will become the designated bridge. And we know that that is switch 2 from looking at the priorities and the bids earlier. Switch 2's fast Ethernet 12 port will be put into forwarding mode and named the designated port for that segment. And I'm sure you caught that because you might have looked at this one and said, wait a minute, here's switch 2. And both of those ports are in forwarding mode too. Yes, but they're not both root ports. See, 11 was chosen as the root port, and then 12 was chosen as the designated port for its common segment with switch 3. Gotta watch that one. So they're both in forwarding mode, but they're not both root ports. So finally, switch 3's fast Ethernet 12 port is going to be put into blocking mode, and it's what we usually call a non-designated port in documentation, an NDP. The DP of a segment is always going to be in forwarding mode, and the NDP is always going to be in blocking mode. So let's go back and look at the switch again, and you can see that finally, after all this talk of stopping switching loops, there's our blocked port, fast Ethernet 12 on switch 3. So out of all of those ports, all 6 of those ports, only 1 was put into blocking mode, and it was fast Ethernet 12 on switch 3. But that's enough for our purposes here of stopping switching loops. So again, a good idea. This is a great demo. I love this one because it shows you, how the root bridge got elected, how the root ports were selected. It verifies it with show spanning VLAN, and also that designated segment over there, the designated bridge. And then, of course, we have our designated port and non-designated port. Now, STP at this point has converged, and all switches have agreed on the root. They've all agreed on all this stuff. At this point, only the root originates BPDUs. That's why I believe I used the word forwarding when we were talking about switch 2 and switch 3. They will now forward BPDUs they receive, announcing switch 1 as the root. They're not originating them, they're forwarding them. The other switches, the non-root switches, will receive them, they'll read them, they'll update the cost, we'll talk about that in an upcoming video, and then forward them, but they don't originate them. The wild thing here, though, the great thing about this topology is that out of the 6 ports, only 1 was put into blocking mode, but that's enough for our purposes. Pretty cool stuff there. On the next video, let's see what kind of trouble we're going to get into. We're going to talk about what happens with some different speeds. I'm going to talk about some STP port costs and some defaults that you should know for the exam. and then we're going to march on with more STP from there. So I'll see you there.